The universe expands, yet the truth remains, still within.
Why does the universe exist? Why does the universe exist at all? It may sound like a simple question, but it is one of the deepest questions ever asked by humanity. Every civilization that has ever looked at the night sky has wondered about this mystery. Why is there something instead of nothing? Why do stars exist? Why does space stretch endlessly in every direction? Why does reality exist at all, rather than absolute emptiness? Modern science has made extraordinary progress in understanding how the universe behaves. We know how stars form, how galaxies evolve, and how gravity shapes the structure of the cosmos. We can even trace the history of the universe back billions of years using observations of distant galaxies and faint radiation left over from the earliest moments of cosmic history. Yet, despite all of this progress, the most fundamental question still remains unanswered. Why does the universe exist? To understand why this question is so difficult, we must begin with what science currently believes about the origin of the universe. According to the most widely accepted theory in modern cosmology, the universe began approximately 13.8 billion years ago in an event known as the Big Bang. At that moment, the universe was incredibly hot, incredibly dense, and extremely small. Space itself began expanding rapidly, and as it expanded, it cooled, allowing matter and energy to take the forms that eventually produced stars, galaxies, planets, and everything we see today. The evidence supporting the Big Bang theory is overwhelming. Astronomers observe that distant galaxies are moving away from us in every direction, indicating that the universe is expanding. The farther away a galaxy is, the faster it appears to be moving away, which suggests that space itself is stretching over time. In addition to this expansion, scientists have detected a faint background radiation known as the cosmic microwave background. This radiation is the afterglow of the early universe, a remnant of the time when the cosmos was only about 380,000 years old. These discoveries allow scientists to reconstruct the early history of the universe with remarkable precision, but they do not answer the most profound question. They explain how the universe evolved after the Big Bang. They do not explain why the Big Bang happened in the first place. When physicists attempt to look back further than the earliest moments of the Big Bang, they encounter a fundamental problem. The laws of physics that describe the universe today begin to break down when applied to the extremely high energies and densities that existed in the very first fractions of a second. Gravity, quantum mechanics, and the known forces of nature behave in ways that we do not yet fully understand under those extreme conditions. This means that our current theories cannot completely describe the beginning of the universe. To answer that question, Scientists are searching for a deeper theory known as quantum gravity. This theoretical framework would combine Einstein's theory of general relativity, which describes gravity and the structure of space-time, with quantum mechanics, which governs the behavior of particles at extremely small scales. So far, finding such a theory has proven extraordinarily difficult, but some ideas have emerged that offer intriguing possibilities. One possibility is that the universe could have emerged from a quantum fluctuation. In quantum physics, empty space is not truly empty. Even in a perfect vacuum, tiny fluctuations of energy constantly occur due to the uncertainty principle. Particles can briefly appear and disappear in pairs, borrowing energy from the vacuum before annihilating each other again. These fluctuations normally occur at incredibly small scales, but some physicists have proposed that under certain conditions, a quantum fluctuation could create an entire universe. According to this idea, the Big Bang may not have required an external cause at all. The universe may have spontaneously emerged from the quantum properties of space itself. Another possibility is that our universe is only one of many universes. Some cosmological theories suggest that the Big Bang was not a unique event, but part of a much larger process. In these models, space may contain countless regions where new universes are constantly forming. Each of these universes could have different physical laws, different constants of nature, and different structures. This concept is known as the multiverse. If the multiverse exists, our universe might simply be one small region within an enormous cosmic landscape of universes. Some scientists believe that the existence of multiple universes could explain why the physical constants in our universe appear so finely tuned for the formation of stars, galaxies, and life. If many universes exist with different physical properties, then it is not surprising that at least one universe would have the conditions necessary for complex structures to emerge. Yet the multiverse remains highly controversial. At present, there is no direct observational evidence confirming its existence. Another fascinating idea comes from theories suggesting that space and time themselves may not be fundamental. Instead, they could emerge from deeper structures involving quantum information and entanglement. In these models, the universe may not be built from particles moving through space, but from networks of information that give rise to the appearance of space and time. If this is true, then the Big Bang may not represent the beginning of everything. It may represent the moment when space and time themselves emerged from deeper physical processes. These possibilities reveal something remarkable about modern science. The deeper we explore reality, the more mysterious it becomes. Instead of reducing the universe to simple mechanical laws, Physics has uncovered layers of complexity that challenge our intuition at every level. The universe is not merely a collection of objects floating through empty space. It is a dynamic and evolving system whose deepest foundations remain unknown. And perhaps the most surprising realization of all is that the universe may not require a reason to exist in the way we expect. In everyday life, we assume that every event must have a cause. Objects move because forces act on them. Events occur because something triggered them. But when we ask about the origin of the universe itself, the concept of cause may lose its meaning. Cause and effect exist within time. But if time itself began with the universe, then asking what happened before the universe may be like asking what lies north of the North Pole. The question may not have an answer within the framework of our current understanding. And yet, the search continues. Every new telescope, every new experiment, and every new theoretical breakthrough brings us closer to understanding the origins of reality. Scientists are studying the earliest galaxies, detecting gravitational waves from distant cosmic events, and probing the behavior of fundamental particles with increasingly powerful instruments. Each discovery reveals new clues about the nature of the universe. But each discovery also reminds us that the cosmos is far more mysterious than we once believed. Perhaps one day, humanity will uncover a deeper theory that explains how the universe came into existence. Or perhaps the universe will always remain partially mysterious. But the pursuit of that knowledge is one of the greatest adventures of the human mind. Because when we ask why the universe exists, we are not just asking about the cosmos. We are asking about the origin of everything. The origin of space. The origin of time. The origin of reality itself. And the search for those answers continues. Still, within